Assalamu alaikum. We have a question on normal and tangential components of acceleration in dynamics. Let us read here what we have. We have a truck travels in a circle path having a radius of 50, so that's the radius of curvature, and the speed of 4 meters per second. For a short distance, starting from s equals 0, its speed increased by this relation. So just for a short duration of time, we have 0.05 s. So this is the acceleration, right? And this is the tangential acceleration. S here is in meters. The question says determine its speed and the magnitude of its acceleration when it has moved s equal 10 meters. So at this distance, we would like to find the speed and the magnitude of acceleration. Right. So now to start with let us start with the speed, right? V. Right. Since now we want to find this, in the question we have v dot. V dot is just 0.05 s, right? And v dot simply is dv over dt. And since now here I have the s, I need to use the chain rule so that we have this relation, which is equal now dv over ds over dt, right? So notice that we can cancel ds at any time and just have dv over ds. Okay, and now this here, ds over dt is just v, right? So now we will have 0.05 s equal v dv over ds. Okay, and I'm just going now to separate the variables. I'll have here v dv equal 0.05 s ds. And now we can integrate both sides of this equation. So we have the integration of v dv and the integration of 0.05 s ds. The limits for my integrals would be for v. Notice that the initial velocity here, when s is 0, we have this 4 meters per second, right? So now here we have 4, right? And we will integrate this to just any velocity, to v. And for the distance, it is from 0 to 10. Okay, so let us carry this integration and find just v. So we'll have something like this, half v square minus 4 square equal 0.05 s square over 2 from 0 to 10. Okay, and just now substituting the limits and solving for v, of course we can cancel this 2 here in the denominator for both sides. We'll have v square equal 16 plus 5, right? So we'll have v equal 4.583 to 4 significant numbers, meter per second. Okay, so we have just found v just like that. Okay, now for the acceleration, we want to find the magnitude for the acceleration. When we have something moving on an object moving on a curve, right? The acceleration will have two components for the acceleration. We have the at, the tangential acceleration, and we have the an. At simply is just v dot, right? And an is simply v square over the rho. Rho here, this is the symbol we use in dynamics, is the radius of curvature, right? So it is just 50. Okay. Okay, so now we need to find at, right, which is given. So I just need to find this. You know, the question says find the magnitude of the acceleration at s equal 10. So now at is simply v dot, which is 0.05 now at 10 meters. So multiply this, just replace this by 10. Okay, so multiply by 10 and I'll get 0.5 meter per second square. And now AM is simply V square over rho. So we have found V to be 4.583 square over the radius of curvature, which is 50. Okay, so over 50. Now I'll put these numbers into the magnitude. You know, the magnitude is A equal root AT square plus AN square, right? So putting this into the calculator, I will have so 0.5 square plus 4.583 square over 50 square, right? So now notice here we have two squares, right? So don't forget the square for the V. And now find the final answer. I find 0.6. I found this number 53 meter per second square. So that's it for this video. Please like and share the video, and let us know in the comment section if you have suggestions or questions. Wishing you all good luck.